Today's presentation will be a description of our journey, how we created a large language model module for Commodore computers. We will be briefly talking about a little bit of background about the history, about the challenge itself. Then we will evaluate the challenge, how it went. There will be a video. I was originally planning to bring the old stuff here to show you live how it works. However, I will also explain why I did not. And let's start. So, Marek Zmysłowski, who's supposed to be here today, is an experienced programmer, pen tester, and manager. Together with Marek, we created a chat enemy, which stands for No Moral Issues. He has a lot of experience, including programming the CUDA. So his part about the AIs in this presentation was replaced with some more information about the Commodore computers. So I'm in cybersecurity for total 15 years in total. I'm first published, as it was already mentioned. I was the first one who publicly showcased a model penetration test using a Commodore 64 as an attacking machine. I was probably the first one who showed the Commodore 64 used as a terminal with locally hosted large language model on home server, and I even locally hosted some web pages using Contiki. I didn't document it, but it was so crazy that for sure I was also the first one to do this. So I'm also a collector. I have well over 120 units of all types of these computers. But one of them is very special. This Commodore 64 was created by me. I ordered a clone of one of the first versions of Commodore 64 from PCB manufacturer. I bought whatever I could, the highest quality, and I put together a beautiful, fully working Commodore 64, which I'm especially proud of. So, this is a very short recap from Dev Camp in Bucharest from 2017, when the Commodore was the first to execute cross-site scripting and the first to abuse the email server in corporate environment. So we were sending fake emails inside the company. There was a first shell shock executed. This was still a thing in 2017. I also wrote a network scanner for Commodore 64, which works. And these are some screens of the only video I have on my YouTube channel when I was using Commodore 64 as a terminal for server with a large language model. So, why? Well, because Commodore 64 has it all, and it is also responsible, probably, for creating the largest community of cybersecurity and hardware specialists in the world. So this is for sure. And I believe that, well, I need to add to the community. So, community already has a lot to offer. This is an example of Bitcoin miner created by a Polish guy. It's not the fastest one, but it works. It really works. You have Super Mario as a result of 7 years of development. The company that originally made this game actually sued the guy who made this port for some reason. One of the Commodore 64 in Poland is still balancing the crankshafts in car engines. There is a Sonic with better audio than the original. We have streaming video and audio in Winamp like applications. We have, again, developed by Polish guys, 3D engines for Commodore 64. And we have Contiki operating system, which is a Linux operating system for memory constrained systems with full support for TCP/IP stack. So it works well. There is one more thing that I will be probably showing next year in Netherlands, which is a result of almost 2 years of work. This one is complicated. But there is also, I need to mention one thing that I missed. I didn't know that on the International Space Station, they have their radio back online. And one of the YouTubers made first contact with using Commodore 64 with International Space Station. And I was not the first one. But I have had everything prepared. Even my radio operator call sign is Sierra Papa 5 Charlie Bravo Mike, which stands for Commodore Business Machine. And I did it for this specific reason, to contact International Space Station, unfortunately. So, about the challenge. Currently, manufactured computers have this capability of external AI modules. Commodore 64 doesn't have it. So, there's such capability. So, obviously, this is simply unacceptable. And here is the challenge. We believe that it must be similar to authentic 80s technology. It needs to be compatible with as many Commodore computers as possible. This is not so obvious because at this time, this was at different times. If you bought a joystick for Commodore 64, it will not work with Commodore 16. Same with dataset, very similar with floppy disk drives. A lot of differences between the line of 8-bit computers. So we also don't want to compromise its functionality. We want to take over the system. We want to be a tool, not a toy. And this solution should be easily replicable to whoever want to, I don't know, make an additional bug selling it on eBay or make it at home. So, will this be our first AI? Well, there were some interesting ideas back then. So you could even train a rat in the maze and it worked. But this was not a large language model. So our implementation would be the first. What we will be needing for a challenge will be some AI programming skills, obviously, and some kind of hardware experience. So, do we have AI programming skills? Well, we published some of the simple POCs on our GitHub, but we also created a commercial version for corporate environment with Retrieval Augmented generation. This is something big, but we won't be talking about it today. Hardware experience. Well, I have a dedicated station to repair and maintain Commodore computers with the usage of the original ways how they did it in 80s, so including the chemicals that they were used. So repaired Commodore by me will have not similar issues to the nowadays equipment in 3 years. It won't break. It will still work for 40 years. No problem. So do we have the skills? I would say yes. Next one. The reason I'm bringing that up is that probably you are more experienced with Breadbean here in US. The Breadbean version was visually different from C version. C version was made a little bit later. This is not really important. There were some changes with the motherboard, with the chips, but this is a fully compatible computer. This version was more popular in Europe specifically. So we need to select the Commodore interface. Remember about the rules of the challenge. So we don't want to overtake the system. We can use expansion port, we can use serial port, dataset port, and the user port. So what would happen if we would use expansion port? We would block a lot of capabilities. Nowadays, if you are using Commodore 64, you have all these fancy modules that will give you a lot of capabilities, external CPU, more memory, fast loading times, whatever. So if we would use it, we would block the possibility of using some fast cards, network card, ultimate cartridge, sidekick, Camelon, whatever, you name it. So we won't going to do that. There is also a serial port, but still there is a lot of modern modules that will read from SD card and push it to Commodore. And this is still used also for some network connections. No, we don't want to block this. Same for dataset port. So the problem is not only with the data exchange, this port is also used to externally power up these modules. So again, we don't want to block this. But there is a user port. The user port was originally used for printers, for modems, for terminal-like stuff. So I believe, well, today we can use it also for some modules like the module that will allow you to play physically by 4 persons on the same machine. But well, we can say that this port is practically unused, and it is compatible between many of the Commodore computers. So you have 64, 128, VIC-20, SX64, etc., etc. So you have a lot of computers with the same port. This is very important. So we have a winner. How the guys in 80s did it, because we want to make it as similar to these solutions as possible. So specifically for you, for this presentation, I decided to unbox my mint condition modem from the 80s and show you what is inside. So inside we will have the modem, we will have some cables, we will have software, and a lot of documentation. I was tempted to send this back because you have already paid for everything there. So we need to have a module, hardware module, and we need to have software. So how this module is in reality, how we can compare it in terms of size. So this is a direct comparison with the Raspberry 4B. So we can see that this is a rather large module, one of the largest for these computers. We need to also choose our software. So there is a lot of computers to choose from, but we don't want to have anything big. We want to have something very small, something that would look like Raspberry Pi Zero. So the choice was a little bit smaller. The problem with Raspberry Pi computers is the memory. So in these computers you will not fit the software we want to push it, but it appears that some Chinese manufacturers just dropped something new. This computer have 8 gigabytes of RAM. We bought it in like pre-order. It was very expensive, $120 per board, something like this. So this computer have a lot of to offer, but it also have a lot of issues that we'll be talking later. It even have NPU, neural processing unit, which we will not be using because it is not suited for our needs in this specific design. We will also need to have something for our software. I was tempted to, again, open some mint condition floppies, but I decided not to do this because I knew that I won't be bringing the stuff here to show you. So I decided to go and make my own cartridge with this software. So I used Magic Desk cartridge generator, and I again ordered some PCBs from China. And this is the config file. I tested the bin in the Vice emulator. This is a standard for emulating software of any Commodore computer. It worked. So we have software, we have PCB. We need to now program our chip. So I used a very basic programmer, but it did the work. This is 64 kilobyte version. It works, and I also printed some case for our cartridge, and this is the result. It works, as you will show on the as you will see in the video. So we were thinking about the LLM itself, how we can approach this, and the first idea was to fine-tune Tiny Lama. Tiny Lama is one of the smallest large language model that actually is capable of doing some interesting stuff. And you can chat with it. You can do a lot of interesting stuff. It's nice. Also, we are heavy lifters in AI, so we have several Teslas. We have a bunch of RTX 4090. We had the capabilities to fine-tune this model professionally. However, what you are seeing here is a list of 368 books from 80s about the Commodore 64 from my collection. These books are not like modern books. These books have 200 up to 500 pages of text. This is a lot of data. So we prepared a synthetic data from it. We made it very professionally. However, because this was a very small model, it didn't really understand the relation between the hardware, software, and air. And we found out that it was hallucinating a lot. And we are not going to make a toy. We don't want to make our user who is talking with LLM on the Commodore 64 asking for Commodore 64. If he is doing this, he is probably well versed about the Commodore 64 and or other computers, and he doesn't need this particular set of answers. So, since we want a tool, we decided to go for the Retrieval Augmented Generation. So Retrieval Augmented Generation is a way of enhancing the answer of the LLM module. This is not fine-tuning. This is not changing the model. The model is still being stateless. We are just pushing additional data provided by the embedding model. How this works? You are putting a lot of different files, 100 PDF files. You are clearing it. You have dedicated translators if the PDF happen to be in different language. This is pushed into the embedding model. The embedding model creates a vector database. When the user asks a question, then this question is then processed by embedding models. The embedding model is retrieving relevant chunks, relevant parts of the text from all these books into the prompt, and along with this prompt, with the instructions, this question is pushed into the LLM model. So this model have the probable answer, the related text inside the prompt. So it is a very easy way to generate a proper answer. For this solution, we decided not to use translators, obviously, because of the memory constraints and the time constraints. So we will be using only the basic functionality. If you want to look it up, this is an excellent paper. And this solution will be very similar to what is called now naive RAG. This is not very different from the racks that are being sold by Big Four to the other corporate environments. So this is still something that is used in the wild. Since we are restrained in terms of memory and processing unit, processing power, we need to have something lightweight also in terms of embedding model, not only the language model. So we found a very small model. This is less than half gigabyte of memory used, and still this is very high in the scoring. So this is actually functioning embedding model. So we have our model, we have our embedding model. Then we need to move to hardware. And again, we know how it should look, how big it is. We have our computer. Now we need to have some kind of interface. And the chip that was very often used in 80s was MAX 232. This was standard for all the terminal type things. So this was the first approach. This was the testing board. It had a lot of capabilities of changing the way the computers were communicating with each other, and it also had the capability, on the right side you can see it, to accept the power from original power supply unit from other Commodore 64. So you could power it up using the original equipment. The second attempt was more straightforward. We were testing a solution that would be user-friendly. The obvious thing here is that this is a first case that were edited before the printing, but we decided to show it because we wanted to show all the steps we made. It fit, but it's flawed, obviously. The version that we will be publishing will be the correct one. So it's demo time. We will show you how it works. Full disclosure. This particular Commodore 64 is upgraded with Luma fix. This is a passive solution for enhancing the video output for the digital grabbers. We recorded it using Panasonic, also audio equipment. There was also a question of the timing, because if it would be live, I would be presenting during the generation. We don't do this, so I edited the waiting time. And one more thing, we wanted to show you the difference between the parametric knowledge of the model, so the knowledge that is already stored in the model, versus the answers provided by the retrieval augmented generation. Tiny Lama knows nothing about Commodore 64, so it wouldn't be a challenge at all. It thinks that it is a game or software, whatever. So we replaced it with a little bit larger model. It still fits. Under some circumstances, if you don't push a lot of documents into the embedding models, it will also fit in the 4 GB version of this computer. I tested it, it works. So it's demo time. So this is the card working, which we select the first option. So it using just the terminal, we are switching some of the parameters. We are switching to lower baud rate, just for you to be able to see what is happening on the screen. We change the type of the ASCII during the communication in order to not mess up big chars, low chars, etc., etc. So the way it works, the computer is waiting for the connection for any key, and here we are seeing the chat. We just ask it about the hardware of Commodore 64, and the next task will be to create a project with the document about the Commodore 64. We are asking the same question, and we are comparing the answer. We will be talking about these things in a moment. So during the design of the software, also I made it like they did it in 80s. If you would look the original Python script that I created, it looked like basic. It was a lot of ifs, and it was a long single monolith. The only thing was that was missing was numbering the lines. But when Marek looked at this code, he said that people will not understand it. Since he's known for his programming skills, it would look bad. People would think that we are retarded or something. So he rewrote it correctly, and this is like a visit card of his programming skills. So the second answer was provided after the creation of the project. The sources were shown, and here we can delete, we can create whatever we want to with these projects. So what happened? The first thing, changing the speed, and one also very important thing. So we could use Nova term. So it would be much nicer for a person who would actually work with this solution with the CRT monitor. You would not have 40 charts per line, but you would have 80. But I wanted to make it nice for the purpose of presentation. So it looks silly, but the text is much more readable. So this is the start. This is asking in chart version. So using the parametric knowledge, the LLM produced some silly answers. So it thinks that there were upgrades in the processor. It thinks that wrongly about many things in terms of screen resolution. It also thought that the Commodore 64 has a mini jack connector, which was unheard of almost in the years when this computer was manufactured. So with the creation of rack project, the system digested the document, it cleared it, it created using the embedding model of vector database, and from using this database, the LLM had a very different answer. So much better. You have proper speed of CPU. You have proper information about the screen resolution. Everything was correct, really. Also, this solution is showing you the chunks. So it is showing you the parts of the text from the books that were used in order to create the response. So you can always reference the answer to the parts that were scored the highest in the vector database, and they were provided by the embedding models along with the prompt. So second source, third source, and the last one. And the rack management. So you can create, delete, update, whatever you want with your projects. So how was the challenge? Again, it must be similar to authentic 80s technology. I believe it is. Should be compatible with as many Commodore models. We make sure about this during the time when we were choosing the interface. So yes, we don't want to compromise 64. So we want all this magnificent add-ons, hardware stuff still be usable with the computer that is using our large language model module. So yes, and should be easily replicable. No, we will talk about that. Create a tool, not a toy. So yes, because we decided not to fine-tune a small model, but instead of this use rack, then yes. So why it is not easily replicable? my idea was to target the people who really don't have a lot of experience with electronics. So this computer is making it hard for these people. You cannot buy this computer without the GPIO that are pre-soldered downwards. So the problem is with mounting cooling. You need to make a hole in the PCB or make something silly. And there is also no cooling for this computer because this is not Raspberry Pi Zero. So it is not very popular. A lot of problems. We found out during the testing that a lot of these computers have UART issues. You need to upgrade the software on board. This particular computer is also not very user-friendly. This is not the computer where you will put SD card, boot the operating system, and have a fun. No. This computer you need to actually flash, similarly to a mobile phone. So this is problematic. Also, the reason why the second attempt with this small chip 232 was looking so strangely is that we didn't find the modules with this chip that would be able to accept these standard pins for development ports. So this is another barrier for the unexperienced home electronics. Even Raspberry Pi 5 have issue with its firmware. There was something wrong with many first editions, and you need to really poke around it and update the firmware. So it's difficult. We should wait for something else to come up before we will make it very popular. So next steps, we will be publishing the cartridge image for you to flash it. We'll publish printed circuit design, and we will do something about this 3D project, so you would have some nice case for it. Why I didn't show it to you live? The first reason is customs. If you ever went through customs in Europe, you will know what I'm talking about. In US, this is completely different. Be my guest. Show me how you will do it with such double-use equipment. And the other thing is that since you have a little bit different power here, and Commodore 64 requires unrectified 9 volts from the power supply unit, I would need to bring something strange like this auto transformer that you can see on right bottom. This is heavy, very delicate piece of hardware. It wouldn't make it to the conference. So thank you for your attention. I believe that this is another testament of the absolute dominance of the Commodore, of Atari, ZX Spectrum, and other competitors. If you have any questions, feel free to approach me or to write us. Thank you.
All right. Thank you very much for this great talk. If there are any questions, now is the time to ask.
Sorry, I'll just ask.
No questions. Everybody understood everything. Oh, there's...
If my C64 has been decommissioned some time ago...
I heard about
yeah, so where can I get a new one?
You can. I don't know if this is recording. So the question was, it's working now. So the question was if we can purchase a new Commodore 64. Purchase, yes. We can also do it ourselves. This was the example how you can do this. You can order the PCB and make it yourself, it will require like a week of work, but you are then in the zone. So it is really, where is it here? So it's really rewarding, but you can also buy an implementation, not an emulation, from Gideon, I believe it's spelled, from Netherlands. The guy is making a hardware of the fully functional Commodore 64. Again, this is not an emulation, this is implementation. So this works great. Still, I'm not fan of it. Since I have access to a lot of original stuff, I prefer to use the original ones. So, can you buy it? Yes. Can you make it? Yes. I believe that Commodore still lives, and well, I really implore you to try it. Next question, please. As you can see on the left, this is this I really don't like. It's collecting a lot of dust. It's visible and it is extremely delicate during the usage. The real problem that you will have is with the keyboard. But the people are also trying to address it. If you don't know, the keyboards from these computers, from this era, are much more resilient to anything you will find in corporate environment. If you have like Dell or whatever, the keyboard that you think that is indestructible and you can like smash someone's head with this keyboard and it will still works. This kind of keyboard was much more resilient. I never had a Commodore 64 keyboard failure. These computers have over 40 years and they work great. So the problem is with the quality of the new keyboard. This is the only issue you may have, but you can buy keyboard from the eBay or from the original one. It will work greatly. 3D printed? I wouldn't use it because it would bend. With the print of this size would bend. You can buy a case from individual computers from Germany also. They made it from plastic. They are very similar to the original ones. They are not really transparent like this one. But they didn't do it quite right. So there are some issues with the screws, the mounting of the keyboard. If you have some unusual mainboard, it won't fit properly. Between the original cases, they are totally replaceable. But the new ones have these little issues.
All right. Are there any more questions?
We have still 4 minutes.
We have still 2 minutes. We have a couple of time, but yeah. If not, feel free. Oh, one question. Yes.
Any further thoughts about doing ham radio with the Commodore 64, SDRs, digital protocols, stuff like that?
So I did some work in using pack radio, I believe, and email sending over the radio. Yes, but the main goal was to connect with the International Space Station. I was not the first, but I have the capability. During the emergency situation, if you are doing some stuff with the civilian defense, you can use it as a terminal. Nobody would see the difference. And let's remember that this computer is pretty efficient in terms of power usage. So, yes. Any more questions? Maybe something about the AI itself, about retrieval augmented generation.
I think we're good on that. But if you have more questions later, feel free to
Yes.
Konrad later.
Feel free to talk with me.
And then Another round of applause for Konrad.
Thank you.